Before we get into this video, I just want to share a small little hack. This video is part 2, where we talk about hooking up a sensor to an Arduino so that you can measure the water level in your tank. I always have trouble trying to strip these wires when I'm using a wire stripper. It always seems to get one of these wires, so what I do instead is I use my handy soldering iron over there and I simply burn off. You can see there's some burn marks here. I simply just put it on there, and then I basically turn this around and burn it all the way around, and then I simply just pull it off. Easy as that. So let's talk about how you're actually going to measure the water level in your tank. I've got a very basic circuit diagram over here. I've got a 30 volts DC power supply. I've got 3 resistors, and I have got a water level sensor. This little dot here, that is the actual sensor. It outputs a very small signal, which we then need to convert, and that's what this block is for. That represents what's called the transmitter. Now the transmitter converts the signal from the sensor to a current of between 4 and 20 milliamps. Out of interest, a transducer will convert the signal from the sensor to a voltage as opposed to a current, but we are using a transmitter, so we will get a current output. Now the Arduino is the thing that I'm using to actually make the measurement, and the Arduino can only measure voltage, and it can only measure between 0 and 5 volts, and that's why I've chosen a 330 ohm resistor. That is to make full range of the Arduino, of what the Arduino can read. And the sensor that I've got here, or the water level sensor, it has got a range of between 0 and 3 meters. But since the tanks only go up to around 2 meters, I basically want to convert between 0 and 2 meters to a voltage of 0 and 5 volts. So when the tanks are empty, I will get a 4 milliamp output, and that would then, the Arduino would then see a voltage of 1.32 volts. When the tanks are full at around 2 meters, the water level sensor would output a current of around 14.6 milliamps, and then we will get a 4.8 volt reading over this middle resistor. And I'm calculating that using the famous equation, Ohm's law: voltage equals current times resistance. So let's talk about the 2 resistors to the right and to the left of the center resistor. Now they are simply there to provide a voltage drop so that the water level sensor sees a voltage of around 24 volts DC, which is its operating voltage. Now since the water level sensor outputs between 4 and 20 milliamps, the voltage drop over these resistance is going to be different because the current will be changing. However, the water level sensor actually can operate over a reasonably wide range, and so we just want to try and get it centered around 24 volts. This 30 volts DC power supply, it actually outputs around 34 volts DC. So if we look at the tanks when they're empty, we will see 3 times 330 ohms times 4 milliamps, and we'll get a combined voltage drop of 3.96 volts. So the water level sensor will see around 30 volts. When you look at full tanks, we will get around 14 milliamps. So it'll be 3 times 330 ohms times 14 milliamps. We will get a voltage drop of around 14 volts over these 3 resistors. So if we take 34 minus 14, we will then get a voltage over the water level sensor of around 20 volts. So now let's go on and talk about calibration. Now before I drop the sensor into the tank, I need to calibrate the sensor, and by calibration I mean finding out what the relationship is between the water level and the voltage reading on the Arduino. Now this is at atmospheric, so you can see it's around 1.3 volts. Alright, and as I said last time, that the water pressure simply depends on the height of a water column. It doesn't matter how big the tank is. So instead of a tank, here's my sensor, I simply have a pipe that's connected. And what I'm going to do is, I'm using this as my baseline, so I'm going to put the sensor in line like that, and I'm going to then put this pipe, all the way up vertically. So the pipe is going to be sitting all the way up to that point. And I'm going to fill the pipe with water. I'm just going to fill it up to up to a certain value. I will do one at the top because I only really need the first 1.8 meters, and then I will take my handy little tape measure. Let me see if I can do this. So yeah, I would then simply put my tape measure next to the column of water. I'll fill it up to near 1.8. That is 1.5, so I'll have to put it a little bit higher. But anyways, I'll fill it up to about that point, and then I will then again check the voltage reading and make that correlation. I'll do it at about 1.8 meters and then probably somewhere in the middle. And then I've already got the value at atmospheric pressure. So now let's talk about the physical connection of the circuit. And what we've got here is, after I've soldered everything together, that's the Arduino you can see there. This wire here is coming from the tank, so I routed that through the ceiling. That is the 30 volts DC power supply. Here we've got the negative terminal of the power supply connected to the first resistor. I've got a solder joint there connecting to the second resistor. Another solder joint, that is the third resistor. Now these two wires are actually the sensor, so it's a negative and positive terminal of the sensor. And this wire now is the positive terminal of the power supply. Now we're going over to the Arduino. This red and black wire are connected over the middle resistor, and that's how I am measuring the voltage. And that's it for this video. The next video I intend on making is part 3, where we'll be talking about the measurement output from the Arduino and how we can process it and store it somewhere. We might even be looking at trying to store it on Google Sheets, for example, so that you can view the readings remotely from wherever you want to in the world. Thanks for watching.